There are a ton of resources, even if you just go to the Geogebra site, and if you do a search for them, there are YouTube videos of people all over the world using this program, showing you how to do things in this program. And there's forums that if you say, I don't know how to do this, will somebody help me, you'll get 40 emails within, half a day saying, here, I've already done it, or this is how you need to type it in. So it's out there. It's free, and there's resources made for it. My price tag, my type of work, it's already done. I like it. And you can take most of these programs and tweak them the way you want them, because when they save them, quite often they'll save everything behind it. So if you want to go in and make a few changes, you can even adjust the one you found to fit your circumstances. It lets me do things I couldn't do before, because we could put a parabola in there and make it an active one, and we could start dragging it around the screen. And have the equations there, it'll let you see what's happening with where these points are going. How's the equation now changing? Which I could have graphed out a bunch of different ones by hand and seen that. But it's not quite as a dynamic understanding when you're actually physically seeing something moving around the screen and you're seeing the numbers change as it goes. When we move to the next part about how do parabolas move left and right, what does that do to the equation, I have one set up that they can type, they're going to have a bunch of different ones already typed in. So they're all there. They don't have to go through and graph it and find all this stuff already. It's there so they can concentrate on the concept we're looking at, is what's happening as this moves left and right or up and down, what's changing in the equation. So they don't have to worry about the calculations and figuring it out. They can just look and make some guesses and hypotheses about, oh, wait a minute, when I moved it this way, that happened, I moved it that way, that happened, up and down. So it looks to me like, as it's moving, this is happening or that's happening. And they could have 10 on there and no time at all to play with and look at. There's one out there using the Pythagorean theorem where they literally have a right triangle with the squares off each side. So they've got the a squared, the b squared, and the c squared, and they can drag two of the legs up and down, and they can see the area of each of those squares changing, and they can see the computation of a squared plus b squared equals c squared. They can see all the numbers changing, but they can see the a squared plus b squared equals c squared stays the same. They're equal to each other. And that, for a lot of my students, was one of those aha moments. They knew how to use it. And they've been told that that means if we put a square here and a square here, the area would be the same as the square off the hypotenuse. But for them to be able to get a hold of something that they could just start physically moving around and also see the computation, numbers changing, but at the end, everything equaling each other. Most of them had that, I get it. Oh, and it's bright, and it's colorful, and it catches their attention. I think it is a good tool for any math. I mean, what I'm really hoping is to back it down lower, because the lower kids also have this on there. It comes pre-installed on our MacBooks. So they have it starting in 7th grade, so I'm kind of working with the teachers down below to get them more comfortable using it, which also forces me to be more comfortable using it. So when they get to me, it's not about how do I type in the squared and how do I do this. It's about, okay, we know how to do that. What can we make it do now? What things can I create with it? What things can you create with it? It's certainly improved their understanding, their deeper understanding, so yes, it's improved their learning. And as I get more comfortable using it, it's only going to get better.